AI coding agent vulnerability. How Cursor's Flaw opened doors to remote code execution. Imagine typing a single line of code that lets hackers take control of your computer. That's exactly what a stealthy vulnerability recently exposed could have done. And here's why it's a wake-up call for everyone using AI-powered tools today. Threat researchers at AimLabs just uncovered a potentially disastrous data poisoning flaw in Cursor, an AI coding assistant. With just one malicious prompt, attackers could turn the agent into a backdoor, giving them full remote command execution rights on devices. How did this happen? The vulnerability, CVE 2025-54135, lives in how Cursor interacts with external servers through its Model Contest Protocol (MCP) system. Think of MCP servers as bridges connecting tools like GitHub or Slack to the AI assistant. But when connecting to these, Cursor was blindly accepting commands, creating an open door for hacks. The exploit process works like this. An attacker embeds a poisoned prompt in a connected tool, like a Slack message. When Cursor fetches this data from the MPC server, it executes the command instantly, before users even approve it. Using this, researchers demonstrated altering Cursor's configuration to add a malicious server with a destructive start command. Boom! Your device is now theirs to control. Why should you care? The patch arrived fast in Cursor 1.3, but the bigger issue is structural. As noted by AimLabs, most AI agents are designed to follow user instructions, making them inherently vulnerable to prompt injection attacks. Here's where it gets controversial. Developers are racing to integrate AI into tools without fully understanding these risks. Is prioritizing innovation over security creating ticking time bombs? The core weakness: AI agents trust external inputs by default, exactly what hackers exploit. But hold on, this isn't just an isolated bug. It's part of a pattern. Last month, AimLabs found Echo Leak, another vulnerability where AI agents leaked sensitive data through prompt engineering. These examples reveal a broader reality. As AI becomes more integrated into workflows, the attack surface exponentially grows. So what now? Organizations might face a dilemma between embracing AI's efficiency and accepting inherent security risks. The solution? Patch vulnerabilities, yes, but also fundamentally reassess how we build and deploy AI agents. The final hook: will transparency in patching these issues be enough? Or does the entire model of agent design need a radical rethink? Comment below. Should we be pushing developers to prioritize security more? Or is some risk unavoidable in the AI revolution? Cursor AI Code Editor Security Flaw. Remote code execution via prompt injection. Imagine discovering a hidden trap in your favorite AI code editor that could let attackers take control of your system. That's precisely what cybersecurity experts uncovered in Cursor, a widely used AI code editor, which harbored a critical security flaw, allowing remote code execution. This vulnerability, identified as CVE 2025-54135, github.com/cursor/security advisories GHSA 4CXXHRM3. With a CVSS score of 8.6, was rectified in version 1.3, https cursor.com/changelog13, released on July 29, 2025. AimLabs, the team that named it Cur Execute, had previously revealed another flaw called Echo Leak. https thehackernews.com/2025-06 0-click AI vulnerability exposes.html. Here's where it gets controversial. Cursor operates with developer-level privileges. When connected to an MCP server that fetches untrusted external data, this data can manipulate the agent's control flow and exploit those privileges. AimLabs explained Security LP, AimLabs Curxecute blog post, that an attacker could feed poisoned data to the agent via MCP, gaining full remote code execution under user privileges. This could lead to ransomware, data theft, AI manipulation, and more. In simpler terms, a single externally hosted prompt injection could silently alter the cursor MCP JSON file and execute attacker-controlled commands. This flaw mirrors EchoLeak, where Model Control Protocol (MCP) servers used by AI models to interact with external systems could fetch untrusted data, poisoning the agent's expected behavior. Specifically, AimSecurity discovered that the mcp.json file https://n-context/mcp.json in Cursor, used for configuring custom MCP servers, could trigger the execution of any new entry without confirmation. This auto-run mode, https://doc/cursor.com/autorun, is particularly risky, as it can automatically execute a malicious payload injected via a Slack message. The attack sequence is startlingly simple. 1. User adds a Slack MCP server via Cursor UI. 2. Attacker posts a message in a public Slack channel with the command injection payload. 3. Victim opens a new chat and asks Cursor's agent to summarize their messages using the Slack MCP server. 4. The agent encounters a crafted message designed to inject malicious commands. AimSecurity highlighted that the core issue is the automatic start of new entries in the global MCP JSON file, meaning code execution occurs even if the edit is rejected. This attack's simplicity is alarming, but it also underscores how AI-assisted tools can introduce new vulnerabilities when handling external content, like third-party MCP servers. AimSecurity emphasized that as AI agents bridge external, internal, and interactive worlds, security models must assume external context may impact the agent runtime and monitor every interaction. Version 1.3 of Cursor also tackles another auto-run mode issue that could bypass the platform's denialist-based protections using techniques like base64 encoding, shell scripts, and quoted shell commands. Following /research team's responsible disclosure, Cursor deprecated the denialist feature for auto-run, opting for an allow list instead. Researchers Mustafa Namne and Micah Gold cautioned, https whiteblog/Cursor AI security flaw auto-run deny list, that built-in security solutions in vibe coding platforms, https thehackernews.com, 2025-03 new rules file backdoor attacklets.html, aren't foolproof. The responsibility lies with end-user organizations to ensure proper safeguards for agentic systems. Hidden Layer further revealed that Cursor's ineffective deny list could be exploited by embedding hidden malicious instructions in a GitHub readme.md file, enabling attackers to steal API keys, SSH credentials, and execute blocked system commands. Researchers Casimir Schultz, Kenneth Yang, and Tom Bonner detailed https://hiddenlayer.com/how hidden prompt injections can hijack AI code assistants like Cursor. How a victim viewing a project on GitHub could inadvertently trigger a prompt injection, leading to the exfiltration of keys. Hidden Layer also identified additional weaknesses, such as leaking Cursor's system prompt by overriding the base URL for OpenAI API requests and exfiltrating private SSH keys using a tool combination attack. These issues were all addressed in Cursor version 1.3. Meanwhile, TracedIt exposed an attack on Google's Gemini CLI. /github.com/Google Gemini/Gemini CLI, an open-source command line tool for coding tasks. The attack exploited the tool's default configuration to exfiltrate sensitive data to an attacker-controlled server using curl. Similar to Cursor, the attack required the victim to interact with an attacker-created GitHub codebase containing a malicious indirect prompt injection in the Gemini MD context file. /github.com, Google Gemini, Gemini.clay, blob 5C4C833DDE1971F6B4E178D7, docs, exploiting Cursor background agents, taking over Amazon EC2 instance. Imagine this. Security experts managed to hack into an Amazon EC2 instance by exploiting vulnerabilities in Cursor's background agents. This revelation underscores the significant risks that come with software as a service, SaaS applications deeply integrated with cloud infrastructure. But here's where it gets controversial. Even with robust security measures in place, these integrations can still be vulnerable to sophisticated attacks. The researchers who uncovered this vulnerability promptly reported their findings to Cursor's security team. Cursor confirmed that they had safeguards in place to prevent such misuse. However, the incident raises important questions about the effectiveness of these safeguards in real-world scenarios. The discovery and attack path. The journey began when the researchers noticed unusual Docker operations during the initialization of Cursor's background agents. This observation triggered a more in-depth investigation. The breakthrough moment occurred when they found a Show Terminal button within the Cursor user interface. This button, originally intended for debugging and transparency, provided direct command line access to a remote machine rather than the local environment. Through this terminal access, the researchers could execute commands on the remote infrastructure, effectively gaining a foothold into the system. The Ubuntu user on the compromised machine had elevated privileges, which were necessary for Cursor's agent to pull packages and install dependencies. Diving into the technical infrastructure. Once the researchers gained root access, they used penetration testing tools like linpeas.sh to conduct a thorough enumeration. This revealed intriguing details about how Cursor's background agent operates. The agent used a server-to-server token to authenticate with GitHub, allowing it to perform actions such as commits and identifying itself as Cursor agent. This token, limited to user repositories, could potentially be abused to gain unauthorized access to these repositories. The infrastructure analysis uncovered Node.js server and client components performing necessary actions as part of the agent's functionality, including crawling operations. The instance was equipped with a substantial 1 terabyte storage capacity within AWS, utilizing a custom Docker image artifactory to manage the process. With root access within the Docker instance and write access to shared storage, the researchers could generate their own SSH key pair. They then wrote the public key to /root/SSH/authorized keys, allowing them to SSH directly to the host machine at IP address 172.17.1. The bigger picture. This incident highlights critical vulnerabilities in desktop applications that have access to cloud infrastructure. While Cursor's machine permissions, AWS roles, and VPC configurations were well-defined and heavily restricted, the potential for privilege escalation through trust relationships remains a significant concern. The full control over the AWS EC2 machine, combined with scoped GitHub server-to-server tokens, opens the door to malicious activities such as cryptocurrency mining or unauthorized data exfiltration. And this is the part most people miss. Even with stringent security measures, the complexity of modern cloud integrations can create unforeseen vulnerabilities. The question remains, how can we better secure these integrations to prevent such attacks in the future? We'd love to hear your thoughts. Do you think current security measures are enough, or do we need a more robust approach? Share your opinions in the comments below.